Okay guys, let's talk about Anova. Just a one-way simple Anova that we talked about in class. So if we want to do a one-way simple Anova, what was the one and the most important prerequisite? That was to have more than two groups or more. We can do Anova with two groups, but it's not gonna give us anything different than doing a regular independent t-test. So I have some information here, and this is a subset of people who were put on a diet, and we have four different types of diets, and their aggression during the diet was assessed. We know that sometimes when we're on a diet we get grumpier. So they wanted to see if there were differences across all of those four diets. And we had quite a bit of data set. I think we have about close to 600 people. So the first thing to do, just out of curiosity, is we want to see how many people we have in each diet group. To do that, we can go under Analyze, Descriptive Statistics, and Frequencies. So we're just looking for the frequencies of the diet. And again, this is just for our information. We just want to make sure that we have approximately the same sample sizes across groups. In class, we've been working only with data sets that have equal number of participants in each group, which is not always the case. But in reality, we want to make sure that there are not huge discrepancies across group. We don't want to have 5 people in one group and 500 in the other. So just on the side, we're gonna check that. And here's our frequency. So we have 4 groups, and we have 100 people in one, about 200 in diet 2 and 3, and 85, which is not great, but it's not too bad. So just for our purposes, we're gonna go ahead and run the one-way Anova. In SPSS, there are 2 different paths that you can go to run the one-way Anova. One is if we go under Analyze and compare means, because that's what we're doing, right? We're comparing means across the 4 groups. We can go down to one-way Anova. And what is our dependent variable? Our dependent variable was the aggression, right? Because we are assuming that the level of aggression of people will be dependent on the diet they were put on. So I'm gonna use that as my dependent variable. And what is the factor, or the independent variable, is the type of diet that they were assigned to. So that will be our factor. All we have to do is click OK. And here's our Anova table. So here's our F statistics, and here that significance column can tell us if our test is significant. So if our critical or significance level is 0.05, since our computed significance is less than 0.05, we can conclude that our test is significant and reject the null hypothesis. If we have to write up our statistical notation for the F test, we can say F with degrees of freedom of 3 and 651 equals 2.895 and then comma P less than 0.05. Or we can just cite the actual p-value, which is p equals to 0.035. So this is one way that we can do the one-way Anova. The other way we can do is if we go back to our data set, and we're gonna go under Analyze, and this time we're gonna go down to the general linear model. And these are all the types of Anovas that you can do. You can use any of those 3 options to pretty much do any type of Anova you want. In our case, we're gonna do the univariate one. go ahead and reset that. So again, we have dependent variable. We said our regression was the dependent variable that we were looking at. And what is our, again, we have a fixed factor. So that they were placed in is what we were looking at. And if we click OK, now the good thing with the univariate path is, in a minute when it shows up, is that we already have embedded the frequencies of each group. So SPSS will automatically tell us how many participants we have in each group. So we don't have to run the frequencies separately. But it's not gonna hurt us if we do. So you guys can use either way to go and do your one-way Anova, depending on which ones you prefer. So our table looks a little bit different than if we went to the one-way Anova path. We actually, all there is we have a couple of extra lines out here that look a lot like what we saw in regression. A good rule of thumb is to look at what variables do we have in our database, and that's the one line that we're interested in. So here we have a diet, and here we have the same F statistic with a significance level. Again, we're rating it the same and we're reporting it exactly the same. F with a 3 and 651 equals 2.895. And here's our p-value just in the last one. Now, since this is significant, we can go back and request a post hoc test. If we were doing the one-way Anova path, we have a post hoc button that we can hit, and we can ask SPSS to give us the post hoc test that we want to. For example, let's do the Bonferroni one. And what this is going to give us is the pairwise comparison, every possible pair across our sample, to see which ones are significant. So in our case, we have 4 groups, so every possible pair across the groups will be done. And the only one that is actually significant is that 3 and that 4. There are no other significant pairs. And the key is that every pair is listed twice. So for example, there's no difference between comparing that 1 and that 4, or that 4 and that 1. It works both ways, but the way SPSS does it, it actually lists every pair twice. But you don't have to report them in twice. One is just enough. And again, if you go under the other path with the univariate, again, it's the same format. We have a post hoc button